So now for indirect standardization. And at the end of the lecture, we'll get to why you would use one over the other. So for indirect standardization, you're internally standardizing. You're calculating a standardized mortality ratio, and it takes the stratum-specific rates from a standard population, and then they're averaged using the stratum sizes of the study population as weights. Okay, so this is also a good table to tell you where you're getting weights from. So similarly, this is for rates, and this is for risks, and it's telling you here that this is your rate in the standard population, and the weight in your population, and this is the rate in the standard. Now here's the risk in your population, the risk in the standard population, and here is your rate. Okay? So this is just the exact mirror opposite of direct standardization. So the information you need to perform an indirect standardization. You need stratum-specific rates for your standard population. Okay, so this is the opposite to direct. And then you need the confounder structure of your study population and or the total number of events in your study population. Okay, so totally the opposite of direct. So how we're going to calculate indirect standardization is first you need to calculate the expected rate. Okay, so this is the rate that you expect to see in your population. So for this example, we're just going to take the age-specific mortality rates in Sweden as the standard to compare the two countries. So here we have the number of deaths in Ecuador, the population, and then you have, so usually you don't have this in your, when you're doing indirect, a lot of the reasons you're doing indirect is because you don't have this information right here, but we just have it because we already did. So here's your age-specific rates for your standard population, so ISJ. So standard population, okay? Here is your population distribution of Ecuador. So what you need to do is you need to take your, this is actually what you normally don't have, is the number of deaths. You need the population structure. So to get the population distribution, you just take the number in this particular stratum, which is 7,498, divided by the total population size. Because you want to know how many or what proportion of your population is within this age category. So for this one, it is 0.65. So for this one, we just have 3,219 divided by the total population as well. Okay, so here's your age structure, and that makes sense based on what we've seen before. It would look like that. We have 65, 28 in here, and 0.07 up here. So then to get your expected rate, so this is what we need to calculate, same thing as before. Now we're going to take your age-specific rate of your standard population, so ISJ, and you're going to multiply it by the population distribution of your study for that particular strata. Okay? So you're taking your rate from your standard, multiplying it by the population distribution of your study population. So similarly for this one, we're taking your specific rate for 30 to 59-year-olds from your standard, multiplying it by your population distribution for your study population, and then you're going to do that again for this one. Now remember, this is a sum, so you're just going to add up your stratum-specific rates, or your products here, which I did not add up. So we have 1.1, that's 1.1, I swear. Looks like Rudolph. 0.7. Joules 4.74. So this is what we would expect to see as our rate if our study population, if the standard population had the same population distribution as our population. Okay, so instead of using the weights from a standard population, we're using the weights from our population. That's why it's called internally standardized. Okay, so now we have our expected rate calculated at 4.74. So now we need to calculate the standardized morbidity or mortality ratio. So all that is your observed rate, so this is the crude rate or risk in that population, divided by the expected rate. Okay? So to calculate your crude, so this is the total number of events in your population, so deaths, disease, whatever, divided by your total population. Okay, so that's your crude, which is the same as your observed. It's going to be 5.65 divided by your expected rate, so that's what you calculated in the slide previously, which equals 1.19. Okay, so that's your SMR. This is where a lot of people will actually stop indirect standardization. If you look at it for textbooks or other resources, they'll usually just report this ratio. But for the class, we are going to keep going. If you multiply the SMR by 100, it will tell you the percent mortality that's higher in one compared to the other. So you can say that it's 19% higher in the Ecuador population compared to Sweden, just because it's higher than 1. Okay? So now for so now we're on to step 3 of the indirect standardization, which is the last step. And all you need to do is calculate the indirectly standardized rate. So what that is you're multiplying the SMR by the standard rate. So the standard rate for this is just the crude rate from your standard population. So for this one, the rate for Sweden was 10.5. Okay, so then all we're going to do is we're going to take our SMR that we just calculated, and we're going to multiply it by the standard rate of our standard population. So this means that our indirectly standardized rate of Ecuador is 12.5 deaths per 1,000 person years. Okay, so that means that even in indirect standardization, our rate is still higher in Ecuador than in Sweden. And because we use Sweden as the population to standardize, the crude rate of Sweden is comparable to this indirectly standardized rate of Ecuador. Because if we use Sweden as the standard population to standardize Sweden with, it wouldn't make any difference, because we've already, the crude rate is taking into consideration the weighting of the distribution of age within that population, like we said before in this lecture. So there you go. You have gone through both direct and indirect standardization methods. It's not too bad. We will go through lots of examples in the class, just so you get really, really comfortable with it. So now you might be interested in, when do I use direct standardization versus indirect standardization? So I personally like flowcharts. So here is a direct versus indirect standardization flowchart. So first of all, the key question is, are the stratum-specific rates or risks available? So if you don't have the number of deaths or events per stratum, so these would be like the age-specific death rates, and these are not available, you have to use indirect standardization, okay? If they are available, the next question you should be asking yourself is, are there small numbers of observations in each strata? Okay, so I've heard that small numbers is 20 or fewer. If no, so you have a very large sample size, direct standardization is your choice, okay? If you have a very small sample size, you should be using indirect standardization. If you use direct standardization with small numbers, the estimated rates are subject to substantial sampling variation because direct standardization does not take into consideration sample size. So we're going to talk about this in a little bit, okay? Indirect can often be used for comparing smaller populations within a larger population. So if we're looking at, say, Guelph and Waterloo and Toronto compared to the Ontario standard, often indirect standardization will be used. However, direct standardization is often preferred to indirect standardization. So we'll talk about that for a little bit. So direct versus indirect. Direct gives greater comparability, but it requires more data. It's not appropriate for small sample size, and it does not recognize sample size used to estimate stratum-specific rates. Indirect standardization, on the other hand, fewer data are required, but it provides less comparability, and it does not allow stratum-specific rates to vary by space or time. So why is direct standardization usually preferred? In direct standardization, the stratum-specific rates of the study populations are applied to just one standard. So the weights are applied are the same for every single one of your study populations. So this makes them very comparable. In indirect standardization, the weights applied to the standard stratum-specific rates depend on the confounder structure of the study populations. So if there are large differences in confounder structure between the study populations, the SMRs calculated are based on different weightings and are therefore not comparable. That's why we generally like direct standardization. The one issue with direct standardization is that you can have potential inconsistencies in the results. So standardized rates are theoretical and based on the standard chosen. So based on the standard, you can have different results. And this is especially apparent when the structure of the populations are very different. So depending on if you're using perhaps a very young standard population, so something like Ecuador, compared to a very old standard population, like Japan, that's a very aging population, those could give you very different answers. So if you use the one standard, it could tell you study A had a higher death rate, but if you use the other standard, study B could say that you had a higher death rate. So it's very, very important to take into a lot of consideration what standard you're going to be choosing. And remember that the standardized rates are theoretical. It's the crude rates that are actually those true rates. If you have small sample sizes, you should be using indirect standardization. If direct standardization was used, the estimates would be subject to substantial sampling variation, and this would lead to imprecise estimates. So if you're looking at rates of rare cancer in different regions of a country, when subdivided by region, there might only be a few cases in each group. If these rates represented a large proportion of the population distribution, it would amplify this instability. Okay, so what we're saying here is say, here is your study population. Okay, let's say there's 6 regions. We have 1 case of cancer here, 4 cases here, 3 here, 2 here, 1 here, and 4 here. Okay? So this should work out to, on average, we have about 2 cases per population. However, if you say we only grabbed these guys from your population, that has now doubled your rate of what it should be. Now let's say these guys all somehow managed to make it into this part of your study population distribution. So in the young category of, say, Ecuador, then this is going to be significantly weighted much heavier compared to all of the other groups in your population. So now you have an unstable estimate because it's so inaccurate compared to what it should be, and then because it's now been weighted based on a very, very large weighting, because it's on a big part of that population distribution, you've magnified that inconsistency even more so. So that's why indirect standardization, direct standardization is not great if you have a very small sample size. However, indirect standardization gives a more reliable comparison because you can choose rates from a large population as the standard, and then you're going to minimize the effects of sampling error. So this one is definitely preferred if you have small sample size issues. So now for some standardized methods review. So for direct standardization, you're going to first calculate the strata-specific rate. So this is your study population. You're then going to multiply the strata-specific rate by the standard distribution in your provided population. So that is your standard population. And then you're going to add the product from each strata to get the final standardized rate. So that's direct standardization. Easy peasy. Like I said before, this is external and internal. Now for indirect standardization, you're going to calculate the strata-specific rate from the standard population. You're going to multiply the strata-specific rate by their study population distribution. You're going to add them all up to get the expected rate. You're then going to calculate the SMR by dividing the observed, aka the crude rate, by the expected rate. Okay? And then you're going to multiply the SMR by the overall standard rate to get the final standardized rate. Okay? So, like I said, I really like this chart. It tells you where the study population is coming from, what it's giving your standardization. So for a directly standardized rate, remember your study population is providing the rates of disease or whatever. Your standard population is providing the weights. And indirectly standardized is the opposite. Your study population is providing the weights, and your standard population is providing the rates. Okay? So we'll go through this in the class, so don't worry if you're not 100% sure on how to calculate them yet. So for some key points, populations are heterogeneous. Any overall measure is a summary of values for a constituent group. The observed or crude rate is a weighted average of subgroup-specific rates weighted by the size of the subgroups. Comparability of weighted averages depends on similarity of these weights. So standardized measures are also weighted averages, with weights chosen to improve the comparability. So all you're doing is reweighting. Crude rates are real, and standardized rates are hypothetical. Direct method of standardization uses weights taken from the external standard population, so they're externally standardized, and indirect standardization uses weights taken from the internal study population, so they're internally standardized. The choice of weights, i.e. the standard, can affect rates and comparisons of rates and comparability to other populations, so choose your standard wisely. Now, what do you need to know for life and your exam? So you need to know differences between crude and attribute or strata-specific and standardized measures of disease frequency. You need to understand how to calculate and interpret directly and indirectly standardized rates, interpret standardized morbidity or mortality ratios, and issues concerning choice of strata, standard population selection, type of standardization, and issues with sample size. Now these are some really fantastic references. I personally do not like VR or MER's reference for standardization. I love it for everything else, but not for this particular chapter, unless you like formula. So this particular website right here gives an amazing paper on explaining standardization. It's about 30 pages, so it's quite long, but they do have sections that are indicated as optional, so you definitely do not need to read them for this course. I find they give a really good explanation of all of the issues we talked about, things like sample size, how to pick your standard, and give a really good explanation of how to standardize. This paper right here is about 3 pages, so it's very, very short. If you like pictures or tables or flowcharts to explain how to do things, or if that's what works for your learning style, this is a fantastic resource. It explains things quite clearly, and it gives you a table to kind of figure out how to calculate the different rates or risks. So I really, really recommend it, especially because it's super short. And then this is actually a course website I found online, and it is quite long. It would probably take you about 2 to 3 hours to go through. But you can actually do calculations, and it gives you a little bit more background than what I gave you guys today. So I recommend it. If you're really confused about standardization, go and run through that. The one thing that they do differently is instead of having a proportion of the standard population, they actually just have expected numbers of events, and then you have to calculate that proportion after. But it's the same besides that. So I definitely recommend all 3 of these resources. Definitely come to the in-class session. We're going to be going through a lot of examples, and I'll also go through some examples at the beginning to kind of reinforce how you would calculate these. And then if you definitely try the practice questions, after you've seen it a few times, you realize that the math is very, very simple for standardization. It was just getting over the original concept of what standardization is. And then if you have any questions, please feel free to come to the lab, and Melissa and I will answer your questions, and hopefully this was helpful and standardization isn't so scary, because it's definitely used a lot in public health, so it's something that you need to be aware of and when it's appropriate to use it. So I look forward to seeing you guys all in class on Monday.